Okay. Good morning. So today we are going to discuss an important topic in complex analysis, that is applications of conformal mapping. So conformal mapping is a transformation that preserves angles but may change the size and shape. So why do we need conformal mapping? In real life, many engineering problems involve complex shapes which are very difficult to solve directly. So we use conformal mapping to convert complex regions into simple ones and solve. Right? So now one by one introduce yourself and say the applications of conformal mapping.
So my name is Purnima and I'll tell about the two applications. Conformal mapping is an important concept in complex analysis where it transforms complicated shapes into simpler ones while preserving angles. This makes difficult mathematical problems to solve easily. In electrostatics, conformal mapping helps in finding electric field and potential in regions with irregular shapes by converting them into simple geometries like circles or rectangles.
Next one. This is Saupatnika. So let me tell you two examples, applications. So in fluid mechanics, it is used to study flow around objects such as cylinders and airfoils. So by mapping complex boundaries to simple ones, calculations of velocity and pressure become easier. So another one is in aerodynamics. So engineers use conformal mapping to design efficient aircraft wings. It helps analyze airflow patterns and improve lift and reduce drag.
Next.
My name is Taranya. And in aerodynamics, in heat transfers, conformal mapping is applied to study heat flow in objects.
Louder.
Conformal mapping is applied to study heat flow in objects with irregular boundaries by simplifying the region for easier temperature. In category, in cartography, it is used to create maps that preserve angles, which is useful for navigation.
Pratibha explains application.
Louder.
In elasticity theory, in can solve problems related to stress and trans in materials, especially when the shape are complex. Finally, in signal processing, comparing mapping is used to transform a signal and system into forms that are tested to analysis and process.
So what is conformal mapping?
So conformal mapping is a transformation in complex analysis that preserves angles between curves, though it may change size and shape.
Okay. Why is conformal mapping used in applications?
It is used to convert complex geometrical regions into simple ones, so that problems can be solved easily.
Okay. How is conformal mapping used in fluid flow?
It transforms complicated flow region into simple shapes like circles, making it easier to calculate velocity and
Louder.
pressure.
Okay. So what is the role of conformal mapping in aerodynamics?
So it is used to design aircraft wings by transforming simple shapes into airfoil shapes, helping in lift calculations.
Okay. How is conformal mapping applied in heat transfer?
It simplifies irregular regions into simple shapes, so making it easier to find temperature distribution.
Okay. Next. How does conformal mapping help in electrostatics?
It converts complex conductor shapes into simple ones to easily calculate electric potential and field.
So what is the use of conformal mapping in map making?
So it helps to represent the Earth on flat maps while preserving angles, which is useful for navigation.
Okay. How is conformal mapping used in solving Laplace equation?
So Laplace equation, it transforms difficult boundary regions into simple one, like circles or rectangles, making the equation easier to solve.
So what is the application in civil engineering?
It is used to study groundwater flow and helps in designing dams and irrigation system.
Okay. How is conformal mapping used in stress analysis?
It helps analysis stress around holes or cracks in materials by simplifying the geometry.